Hello everyone, in this video we are going to learn how to use vectors to solve geometric problems. Firstly, let us see how to find the position vector of a point that divides a line segment in a given ratio. In here, we have a point P that divides a line segment AB in the ratio lambda to mu. So we can express the vector AP and the vector PB. So the vector AP equals to lambda over lambda plus mu times the vector AB. For the vector PB, that equals to mu over lambda plus mu times the vector AB. After you knowing that, you can find the position vector of the point P, which means you know how to find the vector OP. We can firstly see that equals to the vector OA plus the vector AP. We know the expression of the vector AP by using the vector AB. So we have equals to OA plus lambda over lambda plus mu times the vector AB. And the vector AB equals to the vector OB minus the vector OA. So the vector OP equals to the vector OA plus lambda over lambda plus mu times the vector OB minus the vector OA. Now, if we have A and B are two non-parallel vectors, and PA plus QB equals to RA plus SB, where PQRS are coefficient, we can see that P equals to R and Q equals to S. Now, let's see some example question. So in the diagram, the points A and B have position vector A and B respectively. In here, we can know that the vector OA equals to A and the vector OB equals to smaller b from this sentence. Then it said that the point P divides AB in the ratio 2 to 3 and asks you to find the position vector of P, which means you need to find the vector OP. And in this triangle, you can see that the vector OP equals to vector OA plus the vector AP. As you know that the point P divides AB in the ratio 2 to 3. So we can write down that the vector OA plus 2 over 2 plus 3 times the vector AB that equals to the vector OP equals to the vector OA plus 2 over 5 the vector AB. And we know that the vector AB equals to the vector OB minus the vector OA. So we written down that vector OA plus 2 over 5 times the vector OB minus the vector OA. And then you can substitute smaller a and smaller b into this formula. So we have a plus 2 over 5 times b minus a. And we rearrange that, we have 3 over 5 a plus 2 over 5b. And this is the expression of the position vector of P. Now let's move on to see the second question. We have OABC is a parallelogram. P is a point where the diagonals OB and AC intersect. The vector A and C are equal to the vector OA and OC respectively. So we can label them. So OA is smaller a and OC is smaller c. It asks you to prove that the diagonals bisect each other. So what does it mean? The diagonals bisect each other. It means that the point P must be the midpoint of OB and the midpoint of AC. So we can see OB and AC are two important line segments. So let's try to express the vector OB and the vector AC. In the diagram, you can see that the vector OB equals to the vector OC plus the vector CB. And since OABC is parallelogram, which means the vector CB equals to the vector OA. So we have the vector OB equals to the vector OC plus the vector OA equals to C plus A. So we find the expression of the vector OB. Now let's see how to express the vector AC. So in the diagram, we can see the vector AC equals to the vector AO plus the vector OC. That equals to negative OA plus the vector OC equals to negative A plus C. So we find the expression of the vector AC. And then we see that the point P lays on the both AC and OB. So we can have two expressions of the position vector P. Firstly, let's see as P lays on OB. Then we have the vector OP equals to lambda times the vector OB. That equals to lambda times C plus A, where lambda is a constant. Now, as P lays on AC, the vector OP equals to the vector OA plus the vector AP. That equals to the vector OA plus mu times the vector AC equals to the vector A, smaller a, plus mu times minus a plus c, where mu is also a constant. Now we find the two expressions of the position vector P. So what we can write is that lambda times c plus a equals to a plus mu times minus a plus c. Both of them equals to the vector OP. And we rearrange that, we have lambda c plus lambda a equals to a minus mu a plus mu c. Then we have lambda a plus lambda c equals to 1 minus mu times a plus mu c. And then we can compare the coefficient of two vectors. So let us see. Comparing the coefficient of A, the vector A, we have lambda equals to 1 minus mu. Right? And then we compare the coefficient of the vector C. We have lambda equals to mu. So compare these two. We have lambda equals to mu equals to 1 minus mu. So focus on this equation. We have 2 mu equals to 1. Then mu equals to half, which also equals to lambda. We find the value of the lambda and mu. And what does it mean? You can see that from here, that equals to half the vector OB. And in here, that is half vector AC. Which means P is halfway along the line segment. Line segment OB. And in here, which means halfway along the line segment AC. So we can see that P is the midpoint of both diagonals. So we can conclude that the diagonals intersect each other. So we've done the proof. So you can see that from the beginning, we need to prove diagonals bisect each other, which means you need to prove that P is the midpoint of OB and AC. Then we find the two key line segments that are OB and AC. So we find the vector OB and the vector AC. Further, we can express the position vector P by considering the vector OB and the vector AC. Afterwards, we have two different expressions of the vector OB. Then we can compare the coefficient of the vector A and the vector C to get the value of the lambda and mu. which presents the ratio of the line segment OB and the line segment AC. We find that those values is half, which means the point P half the line segment OB and AC. Thus, P is a midpoint of both diagonals. We prove that P is a midpoint. In this case, the diagonals bisect each other. And then we done the proof. So this is the whole process of this question. Now let's move on to see the question 3. The question 3 said that in a journey, a person leaves the hotel O and drives 10 kilometers on a bearing of 120 degrees to reach A, the museum. From A, he drives 8 kilometers on a bearing of 220 degrees to the park at B. From B, he returns directly to O. So before looking the question, we can sketch the diagram to show this whole journey. Now let's start. We have the hotel O over here and drives 10 kilometers on a bearing of 120 degrees. So start from the north and clockwise 120 degrees. And the length should be 10 kilometers. So here is 10 kilometers and we reach the point A. And then start from A on a bearing of 220 degrees. So we have the north and the clockwise 220 degrees. The length should be 8 kilometers. So seems like that. We have the point B. And B returns directly to O, so we link point O and B. Yep, we have done the sketch. So let's look at the question. It asks you to find the position vector of A relative to O, which means you need to find the vector OA. So let us see. Find the vector OA. Now let's focus on the OA. Let me do another sketch to zoom in. So we have the OA. And here is 10 kilometers. And here is 120 degrees. So to find the position vector of A relative to O, in here, we can work out the lines of I and J components for the vector OA. Since we know the length of OA is 10 kilometers, then we can use a right-angled triangle to find the components of I and J. So let's draw a right-angled triangle. So here should be 90 degrees, and also here is 90 degrees. Let us see, this is point C. Then we can have that the angle COA equals to 120 degrees minus 90 degrees equals to 30 degrees. So here is 30 degrees. In this case, we have the OC that equals to 10 times cosine 30 degrees. And AC equals to 10 times sine 30 degrees. So we can write down that the vector the vector OA equals to 10 times cosine 30 degrees I plus 10 times sine 30 degrees G. By using the calculator, you will get the vector OA equals to 5 times square root of 3I plus 5G kilometers. So here is the answer of the position vector of A relative to O. Now let's move on to see the part B question. It asks you to find the magnitude of the vector OB. So let us see, we know the length OA and the length AB. It seems that we can use the cosine rule to find the magnitude of the vector OB. What we are missing is the angle of OAB. Now let's find it. Since we draw a right angle triangle from part A question, we have the, let's see, this is point C. So COA is 30 degrees, which means CAO, that should be 60 degrees. Then we can have the value of the angle OAB. That should be the angle OAB equals to 360 degrees minus 220 degrees minus 60 degrees, right? So writing down that the angle OAB equals to 360 degrees minus 60 degrees minus 220 degrees equals to 80 degrees. So we have the angle OAB equals to 80 degrees. Then we can use the cosine rule to find the magnitude of the vector OB. Let me do a sketch over here so you don't need to look upwards. So we have OAB OA equals to 10 kilometers, AB equals to 8 kilometers, and the angle OAB equals to 80 degrees. So we can write down that. So the magnitude of AB, square of that equals to the magnitude of OA, square of that plus the magnitude of AB, square of that, minus 2 times the magnitude of OA times the magnitude of AB times cosine 80 degrees. That equals to 10 squared plus 8 squared minus 2 times 10 times 8 times cosine 80 degrees. In this case, the magnitude of OB equals to square root of that, which equals to 11.7 kilometers to 3 significant figures by using the calculator. So we have the answer of that. Now let's move on to see the part C question. It asks you to find the bearing of B from O. Which means the question asks you to find the value of this angle. What we are missing is the angle AOB. In here, we can use the sine rule to do that. Let us see for part C. Let me add a line. So note over here, there should be 120 degrees. And we want to find the angle AOB. This angle. So we can use a sine rule to find that. So we want to find the angle AOB, or written down that sine angle AOB, and the opposite of this angle is the magnitude of AB. We know the angle OAB, so we can write down that sine angle OAB, and the opposite length of this angle is the magnitude of OB. Then we can substitute the values into this formula, into this equation. We have sine angle AOB over the magnitude of AB, that should be 8. Equals to sine angle OAB. We know that it is 80 degrees. So sine 80 degrees over the magnitude of OB, what do we have in the question 2 is that. So we have 11.7. Then the angle AOB equals to the arc sine of 8 times sine 80 degrees over 11.7. That equals to 42.3 degrees to 3 significant figures. And we don't stop over here, since the question asks you to find the bearing of B from O. So we need to add this 120 degrees. Then we have that the bearing of B from O is 120 degrees plus 42.3 degrees equals to 162.3 degrees to 3 significant figures. That should not be 3 significant, 4 significant figures. Now let's move on to see the part D question. It asks you to find the position vector B relative to O, which means you need to find the vector OB. Let us see. So we still have this triangle over here, the angle OAB. And we want to find the vector OB, which means you need to work out the length of I and j components for the vector OB. So we can make another triangle. Let us see if we have triangle, right angle triangle like that. Let us say this is point D. Then what we need to do, we need to find the angle of the DOB. Hence, we can express the length of OD and DB. Since we know the length of the OB is 11.7, as we get this answer from the part C. Is it part C? Oh, sorry, from the part B question. So let's move this triangle over here. We have the point O. And B over here. Here is A. So we draw a perpendicular line. Perpendicular to each other, so we have the right angle triangled. We said this is point D. We know OB is 11.7, and we want to find the length of the OD and the BD. The first thing we need to find is to find the angle DOB. So we know the bearing of B from O, which means you know the angle of this. And we know that this is 90 degrees. So we can find the angle DOB by calculating that the angle DOB equals to the bearing of B minus bearing of B from O minus 90 degrees, which equals to 162.3 degrees. Over here, minus 90 degrees equals to 72.3 degrees. So we have that this angle equals to 72.3 degrees. So we get that OD equals to 11.7 cosine 72.3 degrees. And DB equals to 11.7 sine 72.3 degrees. And then you can write down the vector of OB. That equals to 11.7 cosine 72.3 degrees I. But be aware of that, since it is a vector OB, we can see we need to go downwards. So that should be negative 11.7 sine 72.3 degrees G. That equals to 3.56 I minus 11.1 G to 3 significant figures. Oh, kilometers. I forgot to write the kilometers. So we have done this question. So in this lesson, we learned that how to use the vectors to find the position vectors, to solve geometric problems and how to compare the coefficient of two vectors. So here is the end of the video. Hope you enjoyed. Thank you. Bye.